alternating series. What is an alternating series? A series with the whose terms are alternatively positive and negative, that is plus minus etc. ആ ഓർഡറിൽ വരുന്നൊരു സീരീസാണ് ഓൾട്ടർനേറ്റിംഗ് സീരീസ്. ഫോർ എക്സാമ്പിൾ 1 minus 1/2 plus 1/3 minus 1/4 etc. First term positive, second term negative, again positive, negative etc. So this can be written as sigma k from 1 to infinity minus 1 raised to k plus 1 1/k, because k from 1 to infinity means first term should be positive. So if it is k, minus 1 raised to 1 will be negative. So make it as a positive number, we add plus 1, so k plus 1. Okay, so the first term is positive, next term if it is 2 plus 1 3, that is negative. Okay, so these are the terms. So generally an alternating series can be written as a1 minus a2 plus a3 minus a4 etc. That is sigma k from 1 to infinity minus 1 raised to k plus 1 ak. Okay, so this is the general form of an alternating series. So how will you test the convergence for alternating series? Ratio test, root test etc., limit comparison test etc. are tests for checking convergence in the case of all the terms are positive. So but here we are finding new situations in which all the terms are not positive. There may be positive and negative alternatively or in a mixed form. So for that, first of all, if it is an alternating series, that is alternatively positive and negative terms are coming, we can use alternating series test, or it is called Lebanese test. So according to this test, an alternating series sigma k from 1 to infinity minus 1 raised to k plus 1 ak converges if it satisfies the following conditions. First one is that the terms a1, a2, a3 etc. are in decreasing order. That is, first term is greater than second term, then greater than third term etc. etc. a1 greater than or equal to a2 etc. etc. So this is a decreasing order. So terms without sign, okay, without sign the terms are in decreasing order. Second condition is that limit k tends to infinity ak. So find the kth term and apply k tends to infinity, the limit value is 0. So if these two conditions are satisfied, we can say that the alternating series converges. So for example, using alternating series test, find the convergence of sigma k from 1 to infinity minus 1 raised to k plus 1 1/k. So that is this series. So the terms are 1 minus 1/2 plus 1/3 etc. etc. So which are the terms without sign? It is 1 1/2 1/3 1/4 etc. And this is in decreasing order. 1 is greater than 1/2, 1/2 is greater than 1/3 etc. etc. So the terms are in decreasing order. And what about the second condition, that is limit k tends to infinity 1/k. 1/k is the kth term without sign. So what is the limit value? It is 0. 1/k 1/infinity is 0. So by alternating series test, this series converges. Okay, so this series is called a alternating harmonic series. So if all the terms are positive, it will be 1 plus 1/2 plus 1/3 plus 1/4 plus etc. This is an harmonic series. This is a harmonic series and it is divergent. Okay, divergent series. And if the signs are alternatively positive and negative etc., so then it is called alternating harmonic series. This series is called alternating harmonic series. So by Lebanese test or alternating series test, this alternating harmonic series is convergent. So what about the harmonic series? It is divergent. Alternating harmonic series, it is convergent. Okay, so next one, find the convergence sigma k from 1 to infinity minus 1 raised to k plus 1 k plus 3 by k into k plus 1. So here I am expanding, putting values for k. So if k is 1, it is plus 1 plus 3 4, 1 into 2, then negative, because if k is 2 it is negative. If k is 2, 2 plus 3 5, 2 into 2 plus 1 3. Next, if k is 3, 3 plus 1 4, it is positive, 6 by 3 plus 3 6 by 3 into 4 etc. etc. So what about the terms? It is 4 by 2, 5 by 6, 1 by 2, 6 by 12, it is 1 by 2, 7 by 20 etc. So are they decreasing? 4 by 2 is 2, is greater than 5 by 6, it is greater than 1 by 2, etc. So how will you check that it is decreasing order? It is 2. Okay, 5 by 6 is less than 2, less than 1. So it is 2 is bigger. Then 5 by 6 and 1 by 2, which term is bigger? 5 by 6 and 1 by 2. 5 by 6, 1 by 2. Okay, how will you compare 5 into 2? What is 5 into 2? Find the product like this. It is 10. Then 6 into 1. 6 into 1 is 6. So which is bigger? 10 is bigger. So 5 by 6, this part is greater. Again 1 by 2, 7 by 20. 1 by 2, 7 by 20. What is the product? 1 into 20, 20. 2 into 7, 14. So this 20 is bigger. So 1 by 2 is greater than 7 by 20. Okay, so this order happens. Okay, so the terms are in decreasing order. Then what is the limit value? Second condition, limit k tends to infinity, k plus 3 by k into k plus 1. For that, take k outside from the numerator and denominator. So again k remains in the denominator. So 1 by infinity is 0. So by alternating series test, the series converges. Next one, test for convergence. Sigma k from 1 to infinity minus 1 raised to k plus 1 e raised to minus k. So e raised to minus k. So if k is 1, it is e raised to minus 1. If k is 2, minus e raised to minus 2 plus e raised to minus 3, etc. etc. So which are the terms? E raised to minus 1, e raised to minus 2, e raised to minus 3, etc. etc. E raised to minus 1 is actually 1 by e. E raised to minus 2, 1 by e square. E raised to minus 3, 1 by e cube. So 1 by e, 1 by e square, 1 by e cube, etc. So 1 by e is greater than 1 by e square because the denominator increases, so the value of the fraction decreases. So 1 by e is greater than 1 by e square. Again 1 by e square, 1 by e cube, which is greater. 1 by e square is less than e cube, but 1 by e square is greater than 1 by e cube, etc. So the terms are in decreasing order. Again, second condition, limit k tends to infinity uk. That is limit k tends to infinity e raised to minus k. E raised to minus infinity is 0. So both the conditions are satisfied. So by alternating series test, the series converges. Okay.